Welcome back. So we shall be going with the remaining questions. That is question number 7 to 9. We shall be doing that in this video. So the question that is given to us is we're given a square of 14 centimeter. So this is the square we're talking about, okay? So a square of 14 centimeter. That means all the sides. So AB, you look at the graph, you look at the figure and you just keep looking at it, okay? DC and AD is given as 14 centimeter. Okay, because these are the sides. Now, with centers A, B, C, and D, 4 circles are drawn, okay? And with center, clear? From the center itself, there are how many circles drawn? There are 4 circles drawn, okay, from the center of this. So this again serves as the center of the circle, okay, because they have given it as with center. Now, 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. We have to find the area of this shaded region. So if side is this, so I suppose I'm going to be assuming my point, and let me write that as AO. So AB, you get it by AO plus OB. Clear? So what is AO and AB again? AO equal to OB is equal to the radius of the circle, okay? Radius of the circle. Clear? So all of these circles are actually the same. Clear? So this is going to be 14 centimeter. So if AO and OB are both same, so you can write this as 2AO, okay? Clear? So 14 centimeter divided by 2. So your AO is going to be equal to 7 centimeter. So from this portion to this portion, this is going to be 7 centimeter. From here to here, it's going to be 7 centimeter. From this center of the circle to this line is going to be 7 centimeter. And from this center to this center is going to be 7 centimeter. Now we have everything that we need. Okay, so you can write it down. You can say side is equal to 14 centimeter. You can write side of a square. And then the radius is given as 7 centimeter. Now let's just write it down, okay? So in order to find the area of the shaded region, what do you need? You first have to take the area of the square, okay? You take the area of this square and then subtract this part, right? You have to subtract this part. So when you subtract this, okay, and this, okay, 1, 2, 3, 4, okay. So when you subtract that, what you'll end up getting, this is, you'll end up getting the area of the remaining of the shaded region, right? You take the area of the circle of the square, subtract it with this, and then you with this portion, okay, this portion, and this portion will go away. So and then you'll end up getting the area of the remaining portion. Now this is a sector, right? A sector. Yes, you agree? Okay, you go back to exercise 12.1 if you're not sure about sectors. So this is the sector of the circle. But what do we know about a square again? The square tells us that every corner or this in a square, all the corners are going to be, it will have an angle of 90 degree. So now we also know one thing. We know that theta is going to be 90 degree. Okay, therefore in the next portion we can write area of the shaded region, okay, is going to be equal to area of square minus area of sector, okay? But be careful, how many sectors do you see? 1, 2, 3, 4, okay? So you have to multiply it with 4 sectors. We have to find the area of 4 sectors. So area of a square is side square. Now area of a sector is going to be pi r square into theta by 360. That's the formula, right? So side square is going to be 14 centimeter square minus 4 into 22 by 7. See, unless it's mentioned, use pi as 22 by 7, okay? And the radius is 7 centimeter into 90 degree by 360. So cancel out 0, cancel out 4, you can cancel this out, and 7, 7. So you have 196 centimeter square. 22 minus 22 into 7 is 154 centimeter square. So this should give you 42 centimeters square. So the area of the shaded region is 42 centimeters square. Quickly moving on to the next question. This is given to us, okay? So this figure depicts a racing track, okay? So it could be a racing track, it could be a horse racing this track, or it could be a human running this track, okay? Having a race, okay? Clear? But this is the track, the blue area that you can see, this is the track, okay? And it's also given whose left sides and right side are semicircular. So this left side and this right side, you can just draw a line. These are semicircle. Now you can see a semicircle, right? Now the distance between the two parallel line segment is 60 centimeters. So the distance between this line and this line is 60 centimeter. Sorry, okay, it's 60 meter, okay? This is a typing error, a typo, 60 meter. And what is given? And they are also 106 meter long, and they are parallel lines, okay? Remember that. So parallel line means this is again a straight line, and this line, this length is given as 106 meter, okay? And if the track is 10 meter wide, so this track is 10 meter wide, this track is also 10 meter wide, okay? Everyone clear with this? Okay, so this, okay, right now we're only talking about this track. So from this line to this line is 60 meter, okay? Clear? So even from here to this part is 60 meter, okay? Clear? Okay, so we're asked now if the track is 10 meter wide. So this track is 10 meter, this track is 10 meter. So if you take what is the distance going to be from this track to this track? This is 10 meter plus 60 meter plus again 10 meter. So 10 plus 10, 10 plus 10 plus 60 gives you 80 meter, okay? Clear with this? So the distance from this track to this track is going to be 80 meter. Now we have to find the distance along the track around the track along its inner edge. So we have to find out the inner edge, okay? So you can just rub this off for now. So what are we asked to find? We're actually asked to find this inner edge, okay? This inner edge. See, only this inner edge, okay? This is the outer edge. This line, as you can see, the red line is the inner edge. So we're asked to find the distance of this inner track. So if we take the distance from here to here is how much? It is given as 106 centimeter. You add that and you take the distance from here to here. How much is that? It is also given as 106 meter. Therefore, you can write solution. Okay, therefore, what do you have? The first part, let's say distance, okay? Distance around, okay? You can write distance around the track along its inner edge. You write down this, okay? Around the track along its inner edge. This is given as, so if we take 106 meter plus 106 meter, okay? So we have already covered this distance from this end to this end, and from this end to this end. But what are we left with? We're also left with this remaining portion, right? With this remaining portion, yes? So we're left with this remaining portion, okay? Something like this, okay? Clear? Now, for this remaining portion, we'll have to take, we have to take circumference, okay? Because circumference only includes the line, clear? So this is a semicircle, so this is the circumference, okay? So this is the circumference. So the circumference formula is, of a semicircle is, circumference of semicircle, okay? Semicircle is equal to pi r, clear? So pi r plus pi r, because we have two semicircles. One semicircle is here, the other is here. So 106 plus 106 is 212 meter plus 2 into 22 by 7 into r, okay? So that is 212 meter plus 44 by 7 into the radius is going to be from this center to this center, so this would be 30 meter. So this is going to be 30 meter, okay? Okay. Now, so when you calculate this, you'll be getting this as 102 meter plus 1320 meter by 7, okay? So this is going to be, you take the LCM 12 meter into 7, plus 1320 meter divided by 7. So 212 into 7 gives you 1484 meter plus 1320 meter by 7. So 1484 meter plus 1320 meter is 2804 meter by 7. So this is going to be the distance of the inner edge. Next, we're actually asked to find the area of the track, right? So we're asked to find the area of this track. So the area of this track, so when we talk about the area of this track, we're just talking about this given track, okay? So what can I do is, if I take the area of this bigger rectangle, okay, whose length is the same, which is 106 meter, and the breadth is going to be 80 meter, and I subtract it with this area of this smaller rectangle, okay? So this is the breadth is 60 meter and the length is going to be 106. It's going to be the same. And I take the area of the bigger semicircle, okay, and subtract it with the area of the smaller semicircle. Same thing, area of, and I subtract that, then I'll be able to get the area of the track, okay? It's something like this. I take the area of the bigger track and bigger rectangle, and I subtract it with the area of a smaller rectangle, okay? Clear? Or I subtract it with this area of the smaller rectangle, sorry, okay? It should be like this. Area of the smaller rectangle, I will be left with this portion, right? This portion. Now I take the area of a bigger semicircle and subtract it with the area of the smaller semicircle, so I'll be left with this portion only, okay? Same thing for this. So you end up getting the entire track. Therefore, let's go. Therefore, area of the track. Area of the track. So that is, I'll write it as area of bigger rectangle, or the bigger rectangle, okay, minus area of smaller rectangle plus area of bigger semicircle. Okay, you add it up, and out of the area of the bigger semicircle, you're supposed to subtract area of the smaller semicircle. So when you do that, area of the bigger rectangle is going to be 106 meter into 80 meter, because the formula for rectangle is length into b, right? Now area of the smaller rectangle is going to be 106. The length is going to be the same, the breadth is going to be different, okay? You see, this is 60 meters, so this is area of the smaller rectangle, and then area of the bigger rectangle is this bigger rectangle, so the breadth is 80 meter there. Now what is the area of a semicircle? It's going to be half into, area of a semicircle is half into pi r square, okay? I'll take it as capital R because we're talking about a bigger circle, okay? Pi into pi r square. This is the area of a semicircle, so half into pi r square minus half into pi small r square. So 106, let's just keep it for now, into 80 meter minus 106 meter into 60 meter. So what can I take common over here? I can take 1 by 2 and pi as common. So I can take 1 by 2 pi common. So I'll be left with r square minus r square. Okay. So after this, you can take, what is common to this both? You can take 106 meter. So when you take 106 meter, you're left with 80 meter minus 60 meter. Okay. Plus 1 by 2 into, you replace pi with 22 by 7. Your bigger radius is going to be 40 meter square minus 30 meter square. Okay, clear? See, you look at this. This area of the bigger circle, okay, has a radius of 40 and 40. Okay, because the diameter is 80, so the diameter is 2r, so this is going to be 40 and 40. Now area of the smaller semicircle, this length from this end to this end, we know that it is 60 meter, so that is the diameter of the semicircle. So this is going to be 30 and this is going to be 30. Okay, so that's how you get the bigger radius and the smaller radius. So 106 meter into this 80 meter minus 60 meter is going to be 20 meter. You can cancel out 11, so you'll be left with 11 by 7. So you can write this as a square minus b square. So the formula is going to be a plus b into a minus b. Okay, so finally 106 meter into this is going to be 2120 meter square plus 11 by 7 into 70 20, okay, sorry, this is going to be something, okay, it's going to be 40 meters square, 30 meters square, 40 meters squared minus 30 meters square. So this is going to be into 70 meters square into 10 meters square. So this is, you cancel this out, and 7 into 7, okay. So sorry, this is going to be, okay, all right, so this is going to be 2120 meters square plus, this is going to be 10, okay. So wait, let me just see if I've made any mistakes here. Pi r square by 2, so I take 2 common, so I'm left with pi, and I'll be left r square minus r square, okay. So then 2 into 11 and 7, okay. Okay, I seem to have made a mistake, okay. Okay, yes, one more thing I've forgotten, I've completely forgotten, okay. See, I have only included, how many area of bigger circles do we have? We have 2 areas of bigger circle, right? One of this is the bigger circle, this is the other bigger semicircle, yes or not? It's quite messy, let me just rub that off, okay. Then we'll be able to get, see, how many semicircles are there? 2 semicircles are there, right? How many bigger semicircles? One is this side, the other is this side. So because of that, there is a need to multiply 2 here, okay, 2, this is what I forgot, 2, clear? So 2 is supposed to be here again, okay, forgotten completely. So this, you just cancel out 2, okay, from there. Alright, so you're clear with that, okay, because we have 2 area of a semicircle, okay, one on this side and the other, so 2 semicircles of bigger semicircles and 2 smaller semicircles. So you'll be left with, this becomes 22 by 7, okay, 22 by 7. So finally you'll be left with, this is going to be 22, so it's going to be 2200 meters square. So when you add them up, you'll be getting this as 4320 meters square, and this is the area of the track, and this is your answer. Now let's go with the last question, okay, for this video. This video is interesting, okay. A, B and CD are given as 2 diameters of a circle. So AB, you see AB is given as 1 diameter, and DC is given as or CD is given as the other diameter. Okay. Now what do we have? OA is equal to 7 centimeter. So OA is given as 7 centimeter, and that is the radius, right? Look at this. If AB is equal to the diameter, okay. So how do you get AB? You have to add OB plus OA, yes? Yes or not? If you add OB and you add OA, you end up getting AB, and the diameter formula is 2 radius. You already know what OA is. OA is given as 7 centimeter into 2r. But what do we know about OB? OB is also a radius of the circle, so OA is going to be equal to OB, because these are both the radius of a circle. So this is going to be 7 centimeters as well, okay. So from here we already know, okay, 14 centimeter, you can write this 2r, so the radius is going to be 7 centimeter. So OD is also a radius, which is 7 centimeter, and OC is also another radius, which is 7 centimeter. Now we're asked to find only the shaded region, okay. Clear? We have to find the area where you see blue, this blue area, okay. So now we'll first try to find out this area. So what is this ABC? ABCR is the semicircle, okay. You just focus on the graph, okay. Clear? So what do we have? We have a semicircle that looks like this. A, B, C, and this is O. And AB is given, OA is 7 centimeter, this is 7 centimeter. But what do we know about OC? OC is also the radius of a circle, so this is also going to be 7 centimeter. Now if you see the graph, we have a triangle that looks like this, so we're asked to find this remaining area. So how do we find this area? So to find the area of AOBC, okay, or let's see. So in order to find this area, we have to take the area of the semicircle and subtract the triangle, yes or not? If we take the area of the semicircle and subtract the triangle, we'll be left with this part, okay? What do we know about, so let's say for triangle, what triangle do you see? For triangle ABC, what is the base? Okay, base is A and B. What is A and B equal to? Base is AB, which is equal to 14 centimeter, right? You just have to add 7 centimeter plus 7 centimeter. And what is the height? The height is actually OC, which is nothing but 7 centimeters. So we actually know what formula we can use. Next thing, what do we have? We have this circle, this smaller circle, okay? And this smaller circle is OD. But what you must remember, see, OD is, what is given here? OD is the diameter of the smaller circle. But apart from that, what do we know? We also know that OD is the, what do we know? It is given here. OA is equal to, OD is equal to OC, and these are all equal to 7 centimeter, okay? See, this OD is the radius of the bigger circle, and OD is the diameter of the smaller circle. So now let's go, okay? Let's go with this. So if OD is 7 centimeter, okay, I take a center here, so now we have to find, I'll write this as K, okay? So if we want to find the radius of the smaller circle, how do we go about? We already know that the diameter is given as 7 centimeter, and what is the diameter? 2r equals to 7 centimeter. So radius is going to be 7 by 2 centimeter, which is equal to 3.5 centimeter. So the radius of smaller circle is 3.5 centimeter. Now we have everything that we need, okay? So we have to find this area of the shaded region, so let's go, okay? So therefore, area of the shaded region, okay, and that is equal to area of, you see, area of semicircle, okay, area of semicircle minus what else? Area of semicircle minus area of triangle, okay, area of triangle. So when we take area of semicircle and subtract it with the area of triangle, we are left with this portion. Now which area should we include? We should also include this area of this smaller circle. So we can write that as plus area of smaller circle. Okay, smaller circle. Now area of semicircle is going to be pi r squared by 2. Area of a triangle, since we know the base and height, we can use half into base into height. Plus area of a smaller circle is going to be pi r, let me write this as r1 and then r2 square. Okay, so pi 22 by 7 into 2. The radius is going to be 7 centimeter into 7 centimeter minus half. The base is given as 14 centimeter, height is given as 7 centimeter, plus 22 by 7. The radius of the smaller circle is 3.5 into 3.5 centimeter, okay? Don't forget here, below this centimeter. So you can cancel out whatever you can cancel, 7 and 7. So this is going to be 77 centimeter square, 2 into 7. So this is going to be minus 49 centimeter square. You can cancel out 7 and you'll be left with 0.5. So 22 into 0.5 will give you 11 centimeter. Okay, that is, you get this by multiplying 22 into 0.5. Okay, and you'll be left with 3.5 centimeter. So first calculate 77 minus 49. You'll end up getting 28 plus, so first 11 into 35, so it's going to be 5, 5, 3, 3, so this is going to be 385, but there's one number after the decimal point, so you have to put one number here, so this is going to be 28 centimeter square plus 38.5 centimeter square. Okay, so that would give you So 28 centimeter square plus 38 centimeter will give you 66.5 centimeter square. So that is the required answer. So area of the shaded region is going to be 66.5 centimeter square.